We are in section 2.6, looking at part B on using factoring to make predictions with quadratic models. In example 6 here, a company's profit can be modeled by this equation, P of t equals t squared minus 8t plus 20, where P is profit in millions of dollars for a year that is t years since 2005. So my goal right here is to predict when the profit will be or was 8 million. So I'm going to plug 8 in for profit and solve. So my equation for profit is t squared minus 8t plus 20, and I want to set it equal to 8. Okay, so my technique needs to be to get it equal to 0, and then I'm going to try to factor it so that I can solve. So first, I'll have to subtract 8 from both sides. So I'm going to get t squared minus 8t plus 12 equals 0. 20 minus 8 is 12. Then you're going to factor this. Because there is a coefficient 1, you can just use the 12 or think 1 times 12 is 12 and break this down. Okay, so 12 is positive, so I know I need 2 positives or 2 negatives. They need to both be negative in order to add to a negative 8. Then you go into factors of 12 and you think negative 3, negative 4 would be negative 7, which doesn't work, but negative 2, negative 6, that would be negative 8, so that works. Remember that if you have coefficient 1, you can jump right into your parentheses because the only way to multiply to t squared is t and t. So you're going to have t minus 2 and t minus 6 equals 0. That's factored. Now set each of your factors equal to 0 to solve. T minus 2 equals 0, t minus 6 equals 0. Adding 2 to both sides will give you t equals 2, and adding 6 to both sides will give you t equals 6. Okay? So the question, remember, was predict when the profit was or will be 8 million. This t equals 2 and this t equals 6 were the number of years since 2005. So if I add 2005 to each of those, I can get the year values. So my year values are going to be 2007 and 2011. So in 2007 and again in 2011, the profit was 8 million. So there were 2 year values when the profit reached 8 million. It reached 8 million in 2007 and again in 2011. Okay, on the back side of this page, example 7. A batter hits a baseball into the air. The height h in feet of the baseball is given by h equals negative 16t squared plus 80t plus 4. Several parts here. Part A. When is the baseball at a height of 68 feet? So I'm going to take my equation, plug 68 in for h. So I've got 68 equals negative 16t squared plus 80t plus 4. I know I need to get this equal to 0 to be able to factor it. However, it is inconvenient to factor with a negative leading coefficient. So instead of subtracting the 68, we're going to add the 16t, subtract the 80t, and subtract the 4. Move all of those terms to the other side of the equation to get the positive t squared. Adding 16t squared to both sides to make your 16t squared positive. Subtracting 80t is going to give you minus 80t. Subtracting 4 from 68 is going to give you plus 64 equals 0. From here, I would need to factor. First thing I look at is GCF, and if I look at all 3 terms, 16, 80, and 64, they do have something in common. I think they can all be divided by 16. So I have to check the 80, that's what I'm not sure about. So if I check my 80 divided by 16, it does go in evenly 5 times, so we're good. We're going to factor a 16 out of each of these. It's going to be 16 times t squared minus 5t plus, and 16 divided into 64 gives me 4. Okay. I need to factor more. Now I have my trinomial in t squared a equals 1 form, so I can factor it breaking up the 4, and I know it's positive, so that means 2 of the same, 2 negatives, and 2 and 2 aren't going to make 4, but 1 and 4 will. Aren't going to make 5, I mean. But 1 and 4 make 5, so that's going to be perfect. So leave your 16 alone. Then you're going to have t minus 1 and t minus 4. Okay. Now, you need to set each factor equal to 0. Now, that is each factor that has a variable. The 16 doesn't have a variable, so there's no variable to solve for there. So I'm just going to set the t minus 1 equals 0 and the t minus 4 equals 0 to solve. There's only 2 places that have t. Those are the 2 places that you need to solve. So add 1 to both sides. That one would give me t equals 1. Add 4 to both sides. That one's going to give me t equals 4. Okay, so after 1 second and 4 seconds, the ball is 68 feet high. Think about that. That makes sense because you're going to throw the ball. It's going to go up, hit 68, then it's going to come back down, hit 68 before it falls on the ground, right? So there should be 2 times. That's what I need to explain here. So 1 second is on the way up. And 4 seconds is on the way back down. That's why there are 2 answers. Okay, part B. When is the baseball at a height of 104 feet? So we try this again. 104 becomes the height equals negative 16t squared plus 80t plus 4. Move everything to the other side, trying to get your 16t squared positive. So if you add 16t squared to both sides, it's going to become positive. Subtract 80t from both sides, then subtract 4. That's going to leave you with positive 100. Then you're equal to 0. Moving all 3 of these terms to the other side to get your t squared term positive. Plus 16t squared minus 80t minus 4. Okay, there is a GCF. This time, I can't divide 16 into 100, but I can divide them all by 4. So let's factor out 4. It's going to leave you with 4t squared minus, what is 80 divided by 4? I think it's 20. Minus 20t, and 100 divided by 4 is 25. Okay. Now, I need to factor. There is a coefficient this time, so I can either use a times c, or I can use trial and error. Let's try a times c this time. So I'm going to have 4 times 25 is 4 times 25. That's 100. That's positive, so I need 2 negatives, 2 the same to get a positive. Both need to be negative. Trying to get negative 20, so I can use, what goes into 100? I can use negative 20 and negative 5, which would give me negative 25, which doesn't work. I can use negative 10 and negative 10, which gives me negative 20, which does work. Okay, so I'm going to have that 4 out front, big parentheses, then 4t squared minus 10t plus 25, big parentheses, equals 0. Then you're going to group. We chose 10 and 10 because 10 and 10 add to 20, and they multiply to 100. Let's keep working on this. Okay, so 4, 10 both have 2 and t in common. Leaves you with 2t minus 5 minus, this is a 25, that's a 10, they both have 5 in common. That leaves you with 2t minus 5. So now the 4 is still out front. The binomial in common is 2t minus 5, and the other binomial comes from the coefficients. It's going to be 2t minus 5. Sorry, I kind of ran into the paper hole punch there. So I've got 4 times 2t minus 5 times 2t minus 5. That is 4 times 2t minus 5 squared equals 0. The 4 doesn't have a variable part, so the only part that could be set equal to 0 is the 2t minus 5 squared. And if you have something squared equal to 0, if you take the square root of both sides, then you just have 2t minus 5 equals 0 because the square root of 0 is 0. Then you're going to add your 5 to both sides. That would give you 2t equals 5, and then divide by 2, divide by 2. So t equals 5 halves. Okay, so quick little sentence there. After 5 halves, in this context, you're going to want decimal, right? To make sense of this, 5 halves is 2.5. So after 2.5 seconds, the ball is 104 feet high. Okay. Now, explain why there was only one such time. There were 2 times for 68 feet. That's because on the way up, the ball reached 68 feet, and the way down, the ball reached 68. The ball is going to go up and come back down for every height it hits except for one, which is the highest height. So if there is only one time that solves something, that means it has to be the highest height. Okay, there's only one such time because 104 feet must be the highest height reached. Highest height that we reach. Cool. Otherwise, there would have been two answers. So, part C, when is the baseball at a height of 110 feet? I can solve the entire question again, but I just said that 104 feet is the highest, so I know that there is no solution, so never. Remember that 104 is the highest. Okay. If you did try to solve it, you're going to find something that isn't factorable. Okay, so not solvable. So it's a good thing we already knew that it wasn't going to work. Okay. One question left in this section. Let's look at example 8. A rectangular painting, not including the frame, has a width of 9 inches and a length of 15 inches. Okay, so let me draw my painting and its frame. So a rectangular painting, not including the frame. So let's try to draw something like this to show a painting and a frame. So if I'm not including the frame, it has a width of 9 and a length of 15. So it's 9 across here and 15 up here. Okay. If the total area of the painting, including the frame, of uniform width is 247 inches, what's the width of the frame? So the key part here is that the frame has uniform width, which means that it is a measurement of x on all sides, right? It's the same all the way around. Same thickness all the way around. Okay, so that means that the total dimensions of the length and the width for the whole thing, including the frame, since it's 9 across, but there's x here and x here, the entire width needs to be 9 plus 2x, or 2x plus 9. I probably should write the 2x first. 2x plus 9. And the entire length, again, x and 15, so 2x plus 15. Okay. Now, remember that the entire area is 247 square inches, and area is a product of length times width. So if I have my 2x plus 15 times my 2x plus 9, that product, that's area, needs to be equal to 247. Okay. To solve, I need to multiply this out, subtract over to get this equal to 0. First step, multiply out. 2 times 2 is 4. X squared. 2 times 9, so it'd be plus 18x. 15 times 2, so plus 30x. And 15 times 9, that one I don't know. Let's find out. 15 times 9 is 135. Equals 247. Okay, so next we're going to subtract the 247 over. So we've got our 4x squared plus 18x. Oops, I should have gone ahead and done 18 plus 30, which would give me 48x, right? 18 plus 30 is 48. And I need to do my 135 minus my 247, which gives me negative 112. That might equal 0. I can see that 48 and 4 have 4 in common. I think 112 can be divided by 4 also. So let's factor a 4 out. Gives you 4x squared plus 12x minus 112 divided by 4. Oh, good, it comes out as 28 equals 0. Then I can factor using just 28 because the only way to make x is x and x. So let's break our negative 28 down. It's negative, so you need a positive and a negative with a larger positive to get your 12 to be positive. Okay, so 28, that's 4 and 7. So 7 minus 4 is 3, and that doesn't work. 28 is also 2 and 14, so 14 minus 2 gives me 12. That's gonna work. So this factors into 4 times x plus 14 times x minus 2. Remember, I can break it right away into 2 parentheses because I have coefficient 1 of my x squared term. Okay, then There's no variable in the 4, so I can't set that equal to 0, but any part that has a variable I can set equal to 0. So I'm going to have x plus 14 equals 0, and x minus 2 equals 0. Plus 14, so you need to subtract 14 from both sides. X equals negative 14. Add 2 will give you x equals 2. Okay? Now, x, remember, is the width of the frame. The frame couldn't possibly be negative 14 inches, so we only have one possible answer that makes sense right here, that the width of the frame is 2 inches. Both answers did solve the quadratic equation that we formulated, but only one of them can make sense in this context.